So, good day, sir. Today, today I'll be discussing design patterns which are proven solutions in software design. This presentation is structured to gradually build understanding from basic definitions to real-world applications. We will explore what design patterns are, their main categories, and how how they are how they are main categories and how they are applied in modern software systems by the end of this presentation. You should understand not only what design patterns are, but also why they are essential for building a maintainable, flexible, and scalable software system. So, part one is the foundational understanding. So, this part focuses on building a strong foundation before diving into specific patterns. It's important to understand the overall concept behind design patterns. Many software problems repeat themselves across different systems and projects. Design patterns exist because developers noticed these recurring problems and documented effective solutions. This foundational knowledge will help you recognize patterns when you are designing your own systems. So, what is a design pattern? A design pattern is your usable solution to a commonly occurring problem in software design. It is not a piece of code that you copy and paste, but rather, but rather a template or blueprint that guides how classes and objects should interact. Design patterns help developers follow the best practices, reduce errors, and improve code readability. They also create a shared vocabulary among developers when someone mentions a pattern like a singleton or an observer. Others immediately understand the design approach being used. So next is the three main categories of design patterns. So design patterns are generally grouped into three main categories based on the type of problem they solve. These categories are help developers quickly identify which pattern might be appropriate for a specific situation. The three categories are creational, structural, behavioral, and each category focuses on a different aspect of software design, which we'll explore next. So the next slide is the creational, structural, and behavioral. So creational patterns focuses on how objects are created and managed, ensuring flexibility and reuse. Structural patterns deal with these low classes and objects are confirmed to form larger structures. Behavioral patterns focus on communication and interaction between objects. These together categorize and cover most design challenges encountered in object-oriented programming. So the next is in-depth explanation of creational design patterns. So in this section, we focus on creational patterns which are concerned with object-oriented mechanisms instead of creating objects directly using constructors. These patterns involve more controlled and flexible ways to create instances. This is especially useful in large systems where object creation can be complex or tightly coupled. So the next slide is choose one creational pattern. So there are several creational patterns, including singleton, factor method, and builder. Each has specific use cases. For this presentation, we will focus on the singleton pattern, as it is one of the most commonly used, easiest to understand. So, the singleton pattern, it ensures that only one instance of the class exists throughout the application and provides global point access to it. So this is useful when managing shared resources such as configurations, settings, database, connections, or logging systems. The main advantage is controlled access and reduced reuse usage. However, a drawback is that it can introduce hidden dependencies and make unit testing more difficult because the instance is globally shared. So the next part is the structural patterns. So in context, it focuses on how classes and objects are combined to form larger systems. These systems help ensure that changes in one part of the system do not negatively affect others. They are particularly useful when integrating existing systems or third-party libraries. So next is the adapter pattern. The adapter pattern allows incompatible interfaces to work together and acts as a bridge translator between two systems that were not originally designed to communicate this pattern. This is commonly used when integrating legacy systems or external APIs without modifying the existing code. So the next is the adapter versus decorator. So before applying adapter pattern, the client, although adapter and decorator patterns may look similar, they serve different purposes. So the next is adapter versus decorator. Although the adapter and decorator patterns may look similar, they serve different purposes. The adapter changes an interface so that two incompatible classes can work together. The decorator, on the other hand, adds new functionality to an object without changing its structure. Understanding the distinction helps developers choose the correct pattern for their design problem. So the next is behavioral patterns in motion. Behavioral patterns are concerned with how objects interact and communicate with one another. These patterns help define clear responsibilities and reduce tight coupling between components, making systems easier to extend and maintain. So the next is the observer pattern scenario. In a weather application, the observer pattern allows multiple displays to update automatically whenever weather data changes. The weather data acts as the subject, while the displays are observers. When the subject changes state, all observers are notified immediately. This promotes loose coupling and ensures consistency across the application. So the next is choosing a behavior pattern. There are several behavior patterns, such as strategy, command, and iterator. For this presentation, we will focus on the strategy pattern, as it demonstrates flexibility and behavior in selection. So what is a strategy pattern? The strategy pattern allows an object's behavior to be selected at runtime instead of hard coding logic. Behaviors are encapsulated into separate strategy classes. For example, a delivery app may calculate fees differently depending whether delivery is standard, express, or long distance. This pattern makes it easy to add new strategies without modifying the existing code. So next is the applied analysis. This section demonstrates how multiple design patterns can work together in a real-world system. Combining patterns often leads to more flexible and maintainable software solutions. So, an online delivery system. In an online delivery system, the observer pattern notifies customers whenever their orders change in status, such as processing, shipped, or delivered. At the same time, the strategy pattern allows the system to calculate delivery fees dynamically. Together, these patterns improve scalability, flexibility, and user experience. So, evaluation and claim. The statement using many design patterns always makes software better is not exactly true. While design patterns provide proven solutions, overusing them can unnecessarily complicate a system. Patterns should be applied only when they solve a real problem. Good design is about balance, clarity, and purpose, not the number of patterns used. So that's it, and thank you.